The AI storm is coming, but how will it reshape the future of design engineering? In this chat with Ambiq CTO, Scott Hanson, you'll learn about the rise of Edge AI, Ambiq's Apollo 5 processor, and the latest in low-power processing. Let's dive in.
Hello, ipX. We're again, you always know I say this, the world-famous studios of ipX. I don't know why I say that, but I think they're world-famous, and as long as I can live in my own little world, then I'm happy. Anyway, we're joined here by Scott from Ambiq. We've had Scott on before. He's very, very popular. He's a man of great understanding of the world that we live in low power, where Ambiq is particularly strong with its wearable technology. But we're going to talk about the coming storm of AI, and we'll give that some context when we get there. But that's what we're going to talk about, how AI is going to affect the future of design and what the context of that is. But as we all know, when I start these conversations, we always start with those 40 billion devices and those 80 zettabytes of data going around the world every day. I still don't know what a zettabyte is. One day somebody will explain it to me. Scott probably knows what a zettabyte is. But anyway, Scott, give us an update about what's been going on at Ambiq, and then we're going to talk about the coming storm that I've just described. Give us an update.
Well,
thank you for coming on the show, by the way.
Yeah, thank you. I'm happy to be back. This is always one of my most fun experiences. So thanks for having me. I think this all actually leads well into your AI coming storm discussion. So Ambiq, last time we were here, we were talking about the launch of our newest low power processor for Edge AI. It's called Apollo 5 or the Apollo 510 product, which is the first in the Apollo 5 family. Since we last talked, that product is out there. We've got our first few customers getting ready to launch. We have a whole long list of customers starting development so that we'll see launches next year. And I would say more importantly, we're dealing with this coming storm of Edge AI firsthand, right? So if I think through the list of customers using this, the vast majority of them are using it for some form of Edge AI, the Apollo 5 family. This is for your audience that doesn't know, the world's lowest power processor uses the Cortex M55 from ARM. So we're often bringing a Cortex M55 to a market that's used to using something smaller and simpler, maybe a Cortex M0 or a Cortex M4 or an M33. But this is a product that is 5x or more faster in typical signal processing or neural network workloads. Just for example, on the audio benchmark from Embassy, the M55 completes the neural network and signal processing workload about 4 times faster than the M33. And that translates to energy efficiency, right? So we have that product out there. Customers are in some cases overwhelmed with the amount of horsepower that they suddenly have available for some of these hard machine learning and AI use cases. And what we're now getting into is some of the harder parts of development, which is really the software, right? So I'm a hardware guy, and so I hate to say this, but it's 95% of our customers' time being spent on software development. And it turns out it's not so simple to just take a neural network that was, built and trained in the cloud and somehow collapse it down to tiny hardware that runs on the edge. Fortunately, we've given them a platform in the Apollo 5 family that is hyper efficient, super energy efficient, but it still requires a lot of optimization to get that right. So we're working very closely with customers to figure out that problem. I think any company that tells you they've solved that problem is lying to you. It's a unsolved problem. I will tell you that every time we've sat down to look at a neural network, whether it was in-house designed or it's something with a customer, there's always opportunities to optimize its operation. TensorFlow Lite Micro is the predominant framework being used for training and then for runtime for neural networks. So runtime meaning the software that's actually running on the processor doing inference. And every time we've looked at one of the underlying functions there, we realized that we could make it more efficient with some hand coding. We've even gone so far with certain customers as to hand code neural networks on their behalf for certain use cases. So Apollo 5 is out there in the real world. It's being used by all these companies doing Edge AI, and in fact, we're in several cases we're working with the customers to co-develop neural networks for their specific use case. A couple of years ago, it was probably true that most of these customers didn't know anything about neural networks. They saw this coming storm, as you put it, and they knew they needed to do something. But in the last 2 years, they've become remarkably more sophisticated. And we're just trying to embed ourselves with a lot of them to figure out what problems are you still facing? How can we solve that further with next gen hardware? How can we solve it with software development? So anyway, it's a really fun time to be around in this industry. We spent the last 10 years developing, or more than 10 years developing, this platform for energy efficient chips. And it's all finally coming together now, right? Suddenly it's not just low power technology that's come along. It's also neural networks that have come along in a way that suddenly we can solve problems that were unsolvable years ago.
Okay. So I just want to clarify something. There's a very strong chance I misheard this, but just to clarify it, you
Sure.
said that the complexity of the system is helping drive low power. Is that? Did I hear that right?
The computational efficiency, let's say, of the M55 is driving low power.
Right.
So
Sorry. I
for the
understand
same
now.
bundle, no, for the same bundle of work, I can do it a lot faster with the M55. And if that processor is just fundamentally, if I take my M55 versus a competitor's M4 or M33, I'm actually consuming less energy per cycle because of all the cool things that we do with our proprietary spot technology. Now we go one step further and say, well, actually that M55 requires 1/5 the cycle count of the M4, M33. You're getting a massive advantage. And it's shocking to some of our customers because they're not used to that. They think I'm just getting something that's pretty much the same as what I had before, more efficient, a little bit more efficient. That's great. But in fact, it's a pretty big step function. This thing also comes with a ton of memory. So, what we're finding is if you look at old school microcontrollers, they tended to be sized so that you've got, a megabyte of non-volatile memory like flash, and then maybe you have a quarter as much SRAM or an eighth as much SRAM available. Well, with the advent of neural networks, suddenly you actually need to size up that RAM quite a bit, and you need more of an NVM, you need more of everything, you need big, fat, off-chip memory interfaces. So we've made an attempt to provide those to our customers. It has to be still cost-effective, right? You can't go out there with a $50 chip to something that requires a $5 ASP. But we're really maxing out what we're giving our customers in terms of processor performance and memory.
Right. So just before we go on to this coming storm, because that's how we built this whole thing up, just explain to just help the community understand, because what you've described there is a scenario where in the last 2 years, it's not an off-shelf solution. You have to engage. You have to actually make stuff up as you're going along, and you described quite a creative process there to a certain extent. You've described how you have to work alongside a design engineer or a team of design engineers to create a solution. So what's the environment that actually happens, without giving away too much? What's actually, because what we want to encourage is the community to say, okay, I want to embrace this, I want to understand it, but of course there's always a high calorific trade-off when you go into
Sure.
the unknown. So just help the community understand what the trade-off is. Wrong phrase, probably trade-off, but the environment that you have to go into, so that they go into it with open eyes, so they can say, right, okay, off the shelf will get me to about 80%, and then there's going to be some 20% that we're going to be working with somebody like Ambiq, and that's the bit where we're going to have to get clever. So what's the environment that happens in?
So fortunately, there's a lot of different available environments, so to speak, that help here. So all of the stakeholders in the chain are contributing something. ARM, for example, they have this whole SimSys library setup that is so CMSIS library setup. They specifically have a version of that called SimSys NN that has a bunch of reusable library functions that allow you to implement neural networks. Google has the open source TensorFlow Lite micro framework for building and training neural networks. And then there's a whole host of tools that sit above that allow you to develop in a nice looking environment. One of my favorite, let's say, communities and environments is offered by Edge Impulse, who I know you've interviewed extensively on this channel. They have for those that don't know, they have a software as a solution or software as a service product that allows you to develop neural networks. They have Model Zoo. a company like Ambiq has its own model zoo, but then they have a much bigger model zoo available for their users, and they've got a community of over 100,000 people that are developing in this environment. And you go in there and you can select a pull down of what microcontroller do I want to target, and you can go, I want Ambiq's Apollo platform, and boom, you're ready to go. And so that's actually a really good one. And I actually just attended Edge Impulse's Imagine conference. In California a couple weeks ago, and they've pulled together a bunch of their community members. And my takeaway there is, if a couple years ago, embedded developers were kind of wary and afraid of this whole edge AI thing, I walked out of that feeling that they get it. They're embracing it. They've done some of that hard stuff and jumped into, whether it's Edge Impulse's environment or grabbed TensorFlow, Light Micro themselves and just ran with that. They're in the community. They're building real neural networks. They're training them on their desktop GPUs. They're not going to some fancy cloud-based solution. And then they're deploying them, and they're finding problems, right? You get it out there and you go, oh, wow, I'm spending 10 times more cycles than I thought I would. What's the issue? And then they're getting in there and wading through it. And that tends to be the point where a company like Ambiq needs to help, right? So you can kind of get, I would bet that your average listener is able to, whatever they think their capabilities are, they're able to pull down all these tools and start neural network development relatively quickly and get something running on Apollo or any one of our competitors' products. What they may not be capable of doing is then squeezing out all the extra cycles and getting to something that's hyper optimized. But that's what we're working to help our customers do better. And let me just maybe give some concrete examples. In that conference, I heard somebody, an engineer, presented. He had developed a litter box for cats that used AI to detect cat health, right? I mean, this is a company that has no business developing AI-enabled solutions, and it's highly sophisticated.
It's obvious.
Right?
It's obvious,
Yeah.
isn't it? It's obvious. Why wouldn't you do that? Eh?
Exactly right. Right. But it's amazing. You've got a company who's not known for electronics innovation, and they're out there developing neural networks. There was another company that was a software developer for hospitals, and they were developing edge devices for like cough detection, right? So they have no experience building edge devices or building neural networks, and yet they're out here developing really innovative solutions and even doing things that I would have assumed were highly sophisticated, synthetic data development. So this is something we do internally. In order to train networks, you have to make data. You have to make data up, right? Make up fake audio data and mix noise in there and all that. But they were doing it like pros, right? And so I walked out of there really inspired by what the community is doing. So I guess, back to your original question, the message to your listeners is, hey, AI is approachable today. There's a bunch of good communities for developers, Edge Impulse being one great one, but all the different vendors, whether it's Ambiq or ARM or whatever, are contributing something to that whole movement.
Right. I'm glad I asked that question. I didn't plan to ask that question, but I'm glad I did, because I think you gave I think what you've said there is you've given people the confidence to say, no, I can go and play with this, and there's options for me, and it's not going to, don't be frightened of it. So very good.
Absolutely.
Okay.
Absolutely.
So let's get to this coming storm, and you've already you've preempted me, because you talked about memory. Now, very interesting, and it's my job on these is to not talk. My job is to get you to talk. But we found on when we're able to see trends on what people are interested in, because we're able to everybody can go and see the views. Everybody can go and see what people are interested in. But very early on, we found when we started talking about for instance, after we did interviews with you and we started talking about low power and AI with Ambiq, we discovered some coverage on memory went up. Now, as far as I was concerned, why, all due respect to the wonderful memory companies that exist, memory's not been a technological breakthrough or an issue for 15 years, probably, as long as I can remember. Nobody rushes up to me and says, got to talk about memory. And all of a sudden, the stuff that I would have thought intuitively, not that I have a lot of intuition, but I would have thought intuitively, people wouldn't be interested. All of a sudden, people were. Now, we've seen that trend go on and on and on like a cycle. All of a sudden, things that we wouldn't have thought people would be all that interested in, up go the viewing figures. And that's given us the opportunity to have a think about that. And what we call that, or we've just called that with you, Scott. We made that up while we were talking to you. Was the coming storm? Maybe we'll reference you, Scott's coming storm.
I like it. Please do. I like it.
It's because all of a sudden, all bets are off. The advent of AI, obviously, we're talking about edge AI. We talk about how we're doing all our computing on the edge, how we're not sending data up through the cloud. We're saving money. We're doing everything on device. But actually, what's actually going on is the moment we start embedding these AI chips, whoever they are, whatever the format is, whatever device they're in, it strikes me that means the design engineer has got to all of a sudden be thinking about absolutely everything else that's there, because these chips are going to be taking more power. They're going to be taking more data. They're going to be creating more heat. They're going to be creating more stress in the system than anybody has ever recognized. So legacy parts, all of a sudden, people are going to be starting asking questions. So I'm going to start asking very intelligent people like you with huge amounts of knowledge, what is that coming storm, and what are the implications for the community, so they can, like you've just said, 2 years ago, people were afraid of neural networks. All of a sudden, 2 years later, people are playing with them. Yeah. All of a sudden, so that would have been a coming storm. Now, I think that's going to be causing all its own issues. So that's a very long question I've just asked. But what I'm asking is the coming storm of how AI is going to affect your designs and everything that you're doing in the next 3 months, 6 months, 12 months, 18 months. Give us your insight about that.
Yeah, I mean, I always talk about so-called small AI and big AI. And what our customers are dealing with today predominantly is small AI. And this is, they're taking traditional algorithms, some filter that's for wind noise reduction in a headphone or a hearing aid, or heart health analysis in a wearable. They're taking a traditional filter and switching it to a neural network, right? And that's almost a nice baby step, because you have a known function. You can put known input in, you can look at the known output, and then you can go implement the same thing in a neural network and see, does it look the same, right? And hopefully it's much better. The point is that the neural network is not going to be as efficient, right? It should be noticeably different, right? Because you're going to spend more cycles doing the neural network than a hand-tuned algorithm that's existed for decades. We see our customers doing this left and right. Sometimes they advertise about it, sometimes they don't. But it's happening behind the scenes. And in fact, in the lead up to the Edge Impulse conference that was a couple of weeks ago, I was going to be on stage and I was going to reference a few customers. So we reached out to a handful of customers and said, hey, you guys haven't been vocal, but how are you using AI, and can we talk about it? And we had two customers came forward and said, actually, we'd really like you to talk about our AI use case. One of those was a company called BioStrap, and they make a wireless health monitor for first responders or for hospitals. And so, imagine that you've got a fire department, and these people are out in the field every day. They're fighting fires. They're in dangerous positions. You care about what their health looks like, in an acute sense, but you also care about across days and weeks and months. How's their physical health and how's their mental health? Right. And BioStrap has created this tool, this wearable, no display. This is not a consumer device. This is for, the fire captain to know that everybody out there is good, that we don't have any PTSD problems, that we don't have any heart health problems that could hit in the field. Right. And they're using neural networks for a variety of different purposes there, for sleep monitoring. They're using it for certain types of activity detection. They're using it even experimentally for heart arrhythmia detection. And then they actually just announced publicly a deal with another company where they're doing stress detection. Not in the way that, your Garmin or your Fitbit will give you stress, but this is a different way of looking at it. And think about it. I don't need to know that my stress is at a 96 today. What my fire captain wants to know, though, is over the last 8 weeks, has there been a consistent rise in my stress levels?
Yeah, nuance,
relatively speaking,
nuance.
Right? Nuance, exactly. And so these are the types of problems we're seeing. This is what I call small AI, and it's Could it have been done using traditional algorithms? Maybe, but not very well, right? And so they're taking on these problems, and as they get comfortable with these issues, they're discovering a lot of challenges, right? The hardware consumes too much power. Okay, we're solving that with Apollo 5. We have a whole family of other products coming. We have a product that's going to be positioned above Apollo 5 that's going to bring even more compute power. So that, or compute horsepower, I should say. That solves that problem. But then they're finding a bunch of software problems, right? We build neural networks in oftentimes whether it's a cloud environment or in a PC environment where there's effectively infinite compute bandwidth and infinite memory. When you try and map that to a small processor, even one as powerful as the M55, it doesn't map efficiently, right? And so there's learnings there that have to be factored in. And these are some of the things that we as Ambiq are going, okay, we helped customers A, B, and C solve that. How can we codify that in our SDK, or how can we provide a tool that makes it easier for our customers to take that on? So we haven't solved all of those challenges, but we're in the process of doing so. The interesting thing that I see coming in the midterm, call it in the 1 year to 2 year to 3 year time horizon, is the onset of big AI. These are things that we probably could not accomplish with traditional algorithms today. Imagine that you want to have a conversational interface added to any electronic device, whether it's this, or it's your wearable, or any number of other things. That takes a really big neural network to get it done. Think tens of megabytes up to maybe even low gigabytes neural network, and that doesn't map very well to the MCUs of yesterday. And so that's really influencing us moving forward. So we have current products, as I said earlier, that have a lot of memory on chip. We have really efficient off-chip memory interfaces. So, most of these customers don't fit their application on the chip. They're going off chip to NAND flash for big neural network assets. They're going off chip to NOR flash for code. They're going to PSRAM for maybe they're storing a big model out there or some kind of UI information out there. So we've really optimized for that kind of system. Moving forward, we have some maybe toward the end of next year, I'll be in a position to come back and talk to you about this, but we have some interesting innovations that we think will help solve a lot of that problem. So this memory problem is going to become a bottleneck, not for the small AI today, but for that big AI wave that's coming. Yep. We need to solve this memory bottleneck. And I'm excited that our customers in the last couple of years have been doing some of this small AI stuff, but it's almost modest in that, hey, we're doing the same function we did before. We're just doing it slightly more elegantly and with better performance. The big AI is so exciting, and I can't really talk about it. We've got, customers kind of dribble out little pieces of this thing under confidentiality, what their plans are, but I'm astounded by some of the ambition that we're seeing in places like AR glasses or next gen wearables or smart home devices with cameras. Hearing aids. There's some really, really interesting products coming that are fully leveraging AI. So first small AI for the next 18 months, you're going to see a lot of small AI. In the 1 to 3 year time horizon, I think you're going to start seeing a lot of big AI, and that's exciting to me.
Right. So, really, then the answer to that question, so it was my inner thought giggling when you were talking about on chip and off chip. It sounded like off planet to me. That's where my head was going. We were having off planet discussion, but it's a bit like that, isn't it?
Perfect.
It's a bit strange.
Yep, it is. It certainly is. You should think about it that way. If you're a developer, think about it like off planet. Yes.
Yeah. So what you're saying is, rather than worrying about what's already there, you're going to have to start planning for what's going to be coming in the future. That's how you've answered the question. You've answered the question in a completely different way than I intended, but that's absolutely fine. That's probably because I asked the wrong question. So you've interpreted a different way. So what you've said is that when and let's be honest, I can't remember the exact phrase you used, but you're using AI more elegantly to solve a problem that already existed. So you've taken a problem when you use the first example. You said, right, here's a problem that I have, and I'm going to solve it more efficiently. And it was absolutely binary. It was, I have a problem, I'm going to solve it more elegantly. And then you moved on to say, okay, now I've done that. And then you started to then talk about big AI.
Yeah.
And then once you start to interconnect with that big AI, then the ramifications moving forward is then you're going to have strategies, and you use 3 or 4 different examples to explain how you're going to use different types of memory, because I gave you the memory as an example. So you went down the memory route, which is absolutely right, where people are going to have different, they're going to have understand different options all the way along the line to understand how they're going to measure that data, to make that interface, and finally, wherever that data is going, whether it stay on planet or off planet.
Yep.
I think we've on this little discussion, we've discovered all sorts of phrases.
Yeah, we have to propagate these. I'm with you. I'll work with you to propagate these phrases. Wonderful.
So we understand how we're going to move forward, and that's taken certainly how I thought the discussion was going to go in a different way. But it's sort of like the mirror image of what I thought we were going to discuss. So that's very, very interesting. So in summary, very exciting things going on at Ambiq, and you see, I described it as a coming storm. That whirlwind is going to hit us quicker than any of us ever thought. But what you're saying is that AI is going to give us the opportunity to solve not just binary problems, but multiple problems. And that's going to give implication for design moving forward. And these are extraordinarily exciting times. As it just so happened, I just listened to a podcast, just finish off on this. I just finished on our podcast. We have all this fear about AI and how AI is going to destroy the planet and destroy us, and we're all going to die. The implications of AI and medical health are just absolutely, literally mind-blowing. The person that I listened to said that if you can stay alive for the next 5 years, the chances are all-cause mortality will mean you'll probably live to 120.
Ooh.
Because of the changes that AI will bring in medical healthcare.
Incredible.
You're speechless, aren't you?
Yeah. No, I have nothing to say about that. That's wonderful.
Isn't that just amazing? Just holding that thought. But you talk about the fireman. You talked about the fireman. That was your example where you were actually talking about the same phraseology that podcast was using, all-cause mentality, stress. You were talking about heartbeat. You were talking about other things that are going on, nuanced data that other things wouldn't pick up, but using AI and using that whole concept of taking data and understanding it changes everything.
Yeah,
takes us off planet. Should we just leave it there? We're going off planet.
Let's go off planet. I like it.
Scott, thank you very much for that. That was really insightful. Huge enthusiasm, huge understanding of where we're going in the future. And we will talk very soon. I have no doubt. Thank you very much.
I appreciate it. Thanks for having me.